Alright, this is just a brief addendum to the least cost path practicum from last week. I realized that I didn't actually show you how to create the path or to extract the actual walking path or paths from the least cost service. So I'm going to quickly do that right now. To do that, we need to revisit the analysis we did last time. I am going to build an anisotropic cost surface using RWalk from this same particular tower we queried last time. So just like before, I have RWalk. I've got the input elevation map set to the clipped watershed DEM, that friction map we made last time, and I'm going to override it, so I'm just using the same cost surface value, and I have the same starting point. But what I need to do is to, in the optional output tab, I actually have to create that walking directions map because that is needed by the routine that delineates the actual path or paths that somebody would walk along the least cost route. So I'm going to call this, I'm just going to call this anisotropic cost DIR for direction, just to differentiate it from that. And in the settings, I'm not going to change anything here. I am going to do the Knight's Move as before and crank up the memory on my machine to give it as much as possible. And I have to check overwrite because I'm just going to overwrite the one that I made before. So very quickly, it's going to finish up. And now I can close RWalk because in addition to the cost map that I have is the same, basically the same one as before, I now have the map of backlink directions, walking directions along that cost surface. And what we're going to do is go back to raster menu and terrain analysis, and we're going to pick the trace a path r.path module. And here what we will see is we actually need the input direction map, that backlink map, as input. We can let it figure out the format. You know, it all depends on the routine that's used, but it expects the output from RWalk, so we'll leave it as auto. And here we can put in coordinates. So for example, I can pick one of these tower sites that is a little bit further away. I could just click on it with the query tool and then grab those coordinates and paste them into there. And now what we're going to be doing is finding out the path from this tower to the tower that we used as the center point for our costs analysis. And there are some things that we could do here, but first let me just show you the optional tab, because this is where you put the output names. So you can get a vector line file. So I'm just going to call this 2 towers vect, actually I'm going to probably call this path vect, and we can get a raster line, you know, it's a set of cells that is the path. So I'm going to call that 2 towers path rast, underscore there, and if we want to check the box that says accumulate the input values, we need to give it the values that we need to accumulate. And something that we can do is put in our friction map, I think, or let's just see what happens if we put in our anisotropic cost surface. We can either, I think if we do that, we don't want to accumulate them, we want to copy that, because those are already accumulated values. We would want to copy them so that we would get into the raster map. Each cell would be the walking cost along it. And so if we query the last cell, we can figure out what that time to walk would actually be between them. So this should work at this point. We hit run, and our path has completed. Oops. And it shows us the route right here. And if we want, we can see how that looks on the nice shaded relief, which I had configured underneath. And you know, obviously black is the default color, but we can change that to something a little bit more visible, and we can increase the width of the line like so that we can see that really nice vector pathway between these two tower sites. Now it also, it's hard to tell when you're zoomed out, but it also creates the raster line, which looks like that. And here we ought to be able to query it, for example, like so. Let's see if I can get it onto the line. And it tells us the actual cost value. And if we give ourselves some raster stats out to the output, it can basically tell us those numbers along the whole length of it over here if we want to know. So this is the maximum value, that's the actual number of seconds, and we would divide that by 3600 to get the hours of walking time, which we can do in a calculator. So that is 28,255 divided by 3600 gets us, it takes about 7.8485 hours to walk from one tower to the other tower, which is really interesting to know. Now, one last thing which I can show you is that you don't need to use just coordinates to start. You can use an input vector map. So what we can do is, instead of using a single set of coordinates, we can grab the rest of the towers, for example, or any other set of vector points that we want. And we're going to call this all towers, like so. And we're going to hit run on that one. And once that's done, we can see now we have a network of pathways, all leading back to the one site that we used to start this cost surface. Now, if we have multiple sites that we use to input as the cost surface, then these paths will go to the nearest of those multiple sites. But in this particular case, we did just this one, and now we got the walking paths from every other tower to this. And we could go round robin style through every single tower site and run the cost surface and then run the path extraction, and we can get all the possible pathways, the least cost routes depending on where you're starting and where you're going, and we can use that to create a amalgamated cost landscape to understand the pattern of travel routes between all of these tower sites in a landscape.